A portable application, sometimes also called standalone, is a program designed to run on a compatible computer without being installed in a way that modifies the computer's configuration information. This type of application can be stored on any storage device, including internal mass storage and external storage such as USB drives and floppy disks, storing its program files and any configuration information and data on the storage medium alone. If no configuration information is required, a portable program can be run from read-only storage such as CD-ROMs and DVD-ROMs. Some applications are available in both installable and portable versions. Some applications which are not portable by default may support optional portability through other mechanisms, the most common being command-line arguments. Examples might include /portable to simply instruct the program to behave as a portable program, or CFG equals inifile to specify the configuration file location. Like any application, portable applications must be compatible with the computer system hardware and operating system. Depending on the operating system, portability is more or less complex to implement. To operating systems such as Amiga OS, all applications are by definition portable. Portable apps are distinct from software portability, source code written to be compilable into different executable programs for different computing platforms. Portable Windows applications. A portable application does not leave its files or settings on the host computer, which may be convenient or required if you have no administrator privileges on a computer. Typically, the application does not write to the Windows registry or store its configuration files in the user's profile. Instead, it stores its configuration files in the program's directory. Another requirement, since file paths will often differ on changing computers due to variation in Windows drive letter assignments, is the need for applications to store them in a relative format. While some applications have options to support this behavior, many programs are not designed to do this. A common technique for such programs is the use of a launcher program to copy necessary settings and files to the host computer when the application starts and move them back to the application's directory when it closes. An alternative strategy for achieving application portability within Windows, without requiring application source code changes, is application virtualization. An application is sequenced, or packaged against a runtime layer that transparently intercepts its file system and registry calls, then redirects these to other persistent storage without the application's knowledge. This approach leaves the application itself unchanged, yet portable. The same approach is used for individual application components, runtime libraries, COM components or ActiveX, not only for the entire application. As a result, when individual components are ported in such manner, they are able to be integrated into original portable applications, repeatedly instantiated with different configuration settings on the same operating system without mutual conflicts. As the ported components do not affect the OS-protected related entities, the components will not require administrative privileges for installation and management. Microsoft saw the need for an application-specific registry for its Windows operating system as far back as 2005. It eventually incorporated some of this technology, using the techniques mentioned above, via its application compatibility database using its DTOS code library, into Windows XP. It did not make any of this technology available via its system APIs. Portability on Linux and Unix-like systems. Programs written with a Unix-like base in mind often do not make any assumptions. Whereas many Windows programs assume the user is an administrator something very prevalent in the days of Windows 95 may such would quickly result in permission-denied errors in Unix-like environments since users will be in an unprivileged state much more often. Programs are therefore generally designed around using the home environment variable to store settings. The dynamic linker provides an environment variable LD library path that programs can use to load libraries from non-standard directories. Assuming /mnt contains the portable programs and configuration, a command line may look like home equals home user LD library path equals uslib usrw3 mwww.example.com. A Linux application without need for a user interaction on varying directory paths can be achieved with the GCC linker option $origin, which allows a relative library search path. Not all programs honor this. Some completely ignore $home and instead do a user lookup in PASSWD to find the home directory, therefore thwarting portability. Some Linux distributions already have native support for portable apps. There are also cross-distro package formats that don't require admin rights to run, like Autopackage, CDE or Care, but with only limited acceptance and support in the Linux community. See also, List of portable software, WinPenPack. Portable application creators, LibRkey, portableapps.com, UNZ, U3. Application virtualization, Spoon, VMware Ethan App. Live USB, Cedo, Portable VirtualBox, Windows to Go. References